Good afternoon, viewers at home. You are home to Mathematics with Dr. OJ. In this video, we shall talk about Rule 3 of partial fraction with examples. In the Rule 3, we have to each quadratic factor in the denominator of the form ax squared plus bx plus c, which does not have linear factors. There corresponds a partial fraction of the form ax plus b all over ax squared plus bx plus c, where a and b are constants. That is, in this rule, if your denominator does not have a linear factor, then and the form of the denominator is a quadratic one, then we are going to apply this rule 3. We have an example here. Resolve x squared plus 2 all over x squared plus 2x plus 3 into bracket x 2x plus 1 into partial fraction. Clearly, this x squared plus 2x plus 3 cannot be factorized. That's why the rule 3 we apply. If it could have been factorized, we would have used rule 2. We would have probably used rule 1. But in this case, it cannot be factorized. So how do we go about this? Now, instead of factorizing this now, instead of us factorizing this, what do we do? Now we can resolve it into a form that looks like that. So x squared plus 2 all over x squared plus 2x plus 3, we now, into bracket 2x plus 1 will now be what? Equivalent to, you introduce, because in this case, this is a quadratic expression, so it takes this form, ax plus b all over the quadratic expression x squared plus 2x plus 3, then plus c all over 2x plus 1. You observe that c is the third constant here, and it goes with the linear factor and in the denominator. So what do we now do? Just find the LCM. Okay, so finding the LCM here, we have to be very careful so that we don't run into trouble. So our LCM is x squared plus 2x plus 3, into bracket 2x plus 1. So by the time you divide this by this, you'll be left with what? 2x plus 1. So you multiply it with what? Ax plus b. So ax plus b into 2x plus 1. Then 2x plus 1. Cancelling this, you'll be left with x squared plus 2x plus 3. Multiplying c into x squared plus 2x plus 3. Okay, that's what the fraction is equivalent to. So what do we now do here? We do a kind of expansion. So you expand this ax by 2, that's now 2ax squared. The ax times plus 1, that's plus ax, then plus b times c, that's 2bx, then plus b times c, that's plus b times 1 is plus b, then plus c times x squared, cs squared, you're trying to expand, you're opening the bracket, plus c times plus 2x, that's plus 2cx, then plus c times plus 3, that's plus 3c. Okay, with that, and in the left hand side here we have x squared plus 2. That is what we have for the function given. So what do we now do here? We now compare the coefficients of some terms here. In the left and right hand side we have similar coefficients. So we can have now compare x squared, the coefficient of x squared. If you compare the coefficient of x squared here, so you pick x squared here, we have x squared in the left hand side will be equal to 2ax squared. We are taking those one that has x squared, then plus cx squared. So when you divide through by that x squared, divide through, because x squared is common to those terms. So this one will be 1, this one will be what? 2a plus this one will be c. You can call this one equation 1. I hope you are following. Okay, now having considered x squared, let's compare those that have x. We have compared x squared. Let's compare those that have the unknown x. Okay, now let's take them one by one. In the left hand side, unfortunately, there's no term that has x, so we write 0 here. And the right hand side there x. We have ax. We have plus 2bx. What x again? They have plus 2cx. So by the time we divide through by that x, this will be 0 is equal to a plus 2b plus 2c. So we can call that one equation 2. I hope you are following. Okay, call that one equation 2. Now let's compare the constants. The constant in the left and right hand side of our equations. The constant. Compare constants. Compare constant factors. Constant factors. Okay. Now, in the left hand side we have 2. The right hand side we have what? We have constants. We have b. Constant again. We have plus 3c. So we can call that equation 3. So we are now having 3 different equations. We are having 3 different equations. So in equation 1, we can try to, get a new equation such that equation, when we put it into the other ones, it will give us another one, so as to be able to split or to reduce the length of our equations. So in the equation 1, we can say that if c comes to this side, so let's say in equation 1, 1 minus c is equals to 2a. Okay, so dividing both sides by 2 here, we give us what? 1 minus c all over 2 is equals to a. So we can call that one equation 4. So putting that equation 4 into equation 2, let's see what it's going to give us. Putting equation 4 into 2. Put equation 4 into equation 2 gives what? Gives equation 4 into 2. You have what? 0 is equal to 1 minus c all over 2, because equation 2 is that, plus 2b plus 2c. Okay, so if you multiply through by these 2, so as to remove the denominator, just multiply through by 2. Multiply through by 2 gives 0 plus 2 times 0 is 0 is equals to 1 minus c plus 4b plus 4c. Okay, so by the time we evaluate or simplify that, what are we going to have? Okay, we have minus c plus 4c. So we are going to have 0 is equal to 1, minus c plus 4c, that's plus 3c plus 4b. So, which could give us minus 1 is equal to 3c plus 4b. That's another beautiful equation. Okay, now with this, we can compare equation, let's call this equation 5 now. We can compare this new equation with equation 3, because they have the same constant. They have what? They have the same constant. So we now say compare or combine equations 5 and 3. So let's combine equation 5 and 3 together. Combine equation 5 and 3 together. So what do we have? So we're going to have what? Minus 1 is equals to 3c plus 4b. You can also have the other one is 2 is equal to b plus, so we can write this one as 3c plus b. Okay, yes. So now we can eliminate. So by subtracting this equation from this, by subtracting equation 3 from equation 5, we're going to have minus 1 is equal to 3c plus 4b minus 2 is equal to minus 3c minus b. So this we cancel this out. So we'll be left with what? Minus 3 is equal to 4b minus b. That's 3b. So in this case, our b will be what? By the time we write both sides by 3, minus 3 over 3 equals to b. So b is equals to minus 1. So we have gotten b to be minus 1. So that will be very easy now to get other values. Very easy. From equation 3 you can get c, and from equation 4 you can equally get our a. So to get b, let's note okay, put b to be equal to minus 1 in equation 3. So we have what? 2 is equal to minus b plus 3c. That will be 2 is equals to, because our b is now minus 1. So when minus 1 comes and comes, 2 plus 1 is equals to 3c. So 3 is equals to 3c. So 3 over 3 will be what? Is equals to c. Our c is equals to 1. Okay. Now that c is equals to 1, how do you get a? In equation 4, you can have 1 minus c all over 2 is equals to a. And now that our c is equals to 1, so that will be what? 1 minus 1 is all over 2 is equals to a. So 0 is equals to a. So our a is 0. Now with a to be equals to 0, so we just need to what? Do some substitution of the constant we have obtained into our equation. Therefore, ax plus b, all over x squared plus 2x plus 3 plus c all over 2x plus 1 will now be equals to, don't forget our a is 0, so 0 times x is 0 plus, and our b, what is the value of our b? Our b is equals to minus 1, so we have minus 1 all over x squared plus 2x plus 3, then plus our c is equals to 1 all over 2x plus 1. So we can write as 1 all over 2x plus 1 minus 1 all over x squared plus 2x plus 3. That is that for that. So please kindly subscribe to my video channel. God bless you.